So if everything's by power of 10, if you've memorized the King Henry shoots rabid dogs thing with their multiples of 10, then great. You've got that down and you're set and ready to run. The problem with that is that if we shift out of the metric system, say into the English unit system, where it's not multiples of 10, 12 feet, 12 inches are in a feet, okay? 3 feet are in a yard, right? Yeah. Okay. We don't have a direct kind of nice, easy, just shift the decimal kind of conversion. So we need some kind of method to go through and approach and set up the solves for these types of problems. And that's where dimensional analysis comes into play, and that's really what the textbook is really trying to push you to go through and do. It's a formalized notation that allows you to solve conversion problems, which is all 130 is. It's also all 151 is. It allows you to solve those conversion problems in kind of a neat, organized fashion that you don't lose track of units and you can get to the correct answer without doing stuff in your head. Okay? So try to not fight the system, follow the system, it will work. Okay? So general rules, we really pay attention to your textbook, is that we start with what we want. Okay? Nice goal for us to set up. So we should give ourselves an equal to the extreme right of wherever we are working, and then put in whatever unit we want, because the unit is what we're trying to target. Once we have the unit, we can back calculate and determine what the numbers are. Then what we can do is move to what information we have already. Okay? And that information that we have already, we've got to be a little bit careful with, depending on what stuff we're given. And we want to make sure that our units kind of match in the appropriate place. So what I mean by that is if our answer is mass, where should mass show up in our calculation? In the numerator or the denominator? In the numerator, because our answer was mass. And if our answer is mass, where does it show up? In the numerator. If our answer is mass over volume, where should volume show up in our calculation? In the denominator, because where did volume show up in our final answer? In the denominator. So if we can kind of look at those units and real quickly interpret, are they mass, are they distance, are they volume? We can then start to push our units, even though they may be disparate units, okay, or different types of units. We can then at least put them in the proper location, and we should be able to go through and solve by doing the conversion of those units. Okay? So, what is the mass in grams of a 325 milligram aspirin tablet? Now, I'm going to go through and work this one. I don't remember. Did we do this one? No. Okay. I think I'm finally now on the right wavelength. Okay, so to go through and approach this, I want to start with what I want as an answer. What do I want as an answer? Grams. So equals grams. What do I start with?
325.
Okay, I heard a couple answers there. The first answer I heard I liked. The second answer I liked less, but it was still accurate. Okay. First answer was milligrams. Okay. Second answer was 325 milligrams. Why do I like the second answer less?
Because jumping steps.
We're bringing in the numbers. I don't care about the numbers. Okay. The units are going to allow me to solve the question. The numbers I can bring in later once I know where to put everything. Okay. You'll notice that milligrams is in the numerator. Why do I want milligrams in the numerator? Milligrams is a measure of mass. What answer do I want? Grams, which is a measure of mass. Both of them are in the numerator, so I can maintain that. The next part of this is a really simple question. Is milligrams equal to grams? No. Okay? It may seem like a dumb question, but maybe we went through all this work and we actually gave you the answer in the question just to see how much work you would try and write out. Okay? That's actually not a bad idea. I might do that. Okay? So we look, check, units aren't right. So what has to happen? I need some kind of conversion factor. Okay? Within that conversion factor, we need two places to identify, our numerator and our denominator. Which do you want to look at first? Numerator. What unit should show up in our numerator? Why grams? That's what we're trying to get to. Okay? what unit should show up in our denominator? Why milligrams? We need those units to be in opposite locations so that they can cancel with each other. If they cancel, I no longer have the milligram unit, and I now have a gram unit. That works out nicely. Now that I've got my units in here, I ask the next question, which is, can be harder. Do I know a conversion factor between grams and milligrams? Yeah. Okay. This is one that everybody should know. You are required to have this one memorized. Okay. We're looking at the milli prefix on grams. What does milli mean? Milli means 10 to the minus 3. 10 to the minus 3 grams is 1 milligram. Okay. Those of you furrowing your brow, give me a second. We'll show the other option. Okay. Units cancel. What ends up happening? Now all I got to do is multiply 325 times 10 to the minus 3. My calculator spits out an answer, and I've got my proper units. Everything's solved. Okay. For those of you furrowing your brows, we had 325 milligrams. This makes me kind of nervous because everybody universally jumped in with this. What did you say milli meant? 1,000. Milli does not mean 1,000. Milli means 10 to the minus 3. Okay. 1,000th. What you are remembering is your mathematical shifts of notation. You're remembering that there are 1,000 milligrams in 1 gram. Does your answer change? No. What this is going to come down to is how have you memorized those Greek prefixes? If you've memorized it according to this 1,000 milligram, I'm fine with you doing that. The issue with that is not how the textbook presents it. All of your prefixes are presented where our milli means 10 to the minus 3. That 10 to the minus 3 acts on grams. So it's 10 to the minus 3 grams is 1 milligram. The reason why is then your power of 10 always goes in front of the base unit. If you switch to this other format, it's not that you're wrong, but there are cases where you will put your power of 10 in front of the non-base unit or the base unit, depending on what you're converting. So be very careful with that approach, because your power of 10 will swap in different locations. Anytime you're not consistent is a time that you will be not consistent and ultimately wrong on the exam. Okay, so what I'm trying to set you up with is the most consistent patterns to get you through, so that as long as you maintain that consistent pattern, you're never wrong. Okay? Where does that power of 10 change? What numbers do I put into this? 1,000 grams is 1 kilogram. You just put the power of 10 in a different spot. Okay? That's where I want you to be careful. As long as you're consistent, you are fine. So watch who you follow as far as their work goes. I try to be as consistent as I can. I will make mistakes like that. Okay? Questions on that one?
So the answer is?
I don't know. 325 times 10 to the minus 3. 10 to the minus 3 means we're shifting our decimal place 3 places. We get 0.3. Whoops. Whoa. What the heck just happened there? 325. Whoops, not milli. Grams. That would be our answer. All right, now I'm going to be a bit obnoxious and throw another one at you that you probably haven't had memorized yet. But let's see what you can do. This one's a little bit more complicated because it requires 2 steps. Okay. Again, depending on how you go through and solve. I will show you how I solve, which requires 2 steps because my memory sucks. Okay. If you've got questions, raise your hand. What do we want as an answer?
Micrograms.
We want micrograms. So it's that goofy little mu symbol gram. What did we start with?
Milligrams.
Milligram. Hey, cool. You guys are catching on. Okay. Does milligram equal microgram? No. So that means I need some conversion factor in here. And this is where we can part separate ways if you want to. You can skip steps with this. I do not recommend you skip steps, because more often than not you shift the decimal the wrong place. Okay? My goal is the same thing as we did before. What unit do I want in the numerator? I want microgram. What unit do I want in the denominator? Milligram. Do I have a conversion between micro and milli? If you can point to me in the textbook where it gives you the conversion between micro and milli, I will accept yes as an answer. You will have a very hard time doing that.
Or write it in.
Writing it is a fair, valid way to approach that, but let's try and not dodge the rule in this case. I don't know that conversion, but I do have a conversion from micrograms or milligrams into grams. Because I can take that Greek prefix and I can convert that away. So what I will go through and do, and it does not matter which one we want to deal with first, be it the microgram or the gram. Okay? But I'm going to try and get rid of my milligram unit by converting it now into grams. What does milli mean? A thousandth. Milli means 10 to the minus 3 grams is 1 milligram. What units am I now in? I'm now in grams. Is grams equal to micrograms? No. So I need to get rid of grams, and I need micrograms in the numerator. Do I have a conversion between micrograms and grams? Yes. That comes from what the meaning of micro is. Micro means 10 to the minus 6. 10 to the minus 6 grams is 1 microgram. Now when I track my units, what happens to the grams? They cancel. What happens to the milligrams? They cancel. What units do I have? Micrograms. I'm now in the proper unit, so now I can deal with my numbers. How many milligrams did I actually start with? 325. Which brings us to the next point. How do I enter this into the calculator? This may seem tedious for some of you. Right? Based on my experience, I'm awful at entering things into a calculator. So what I will end up adjusting, I just need a little more space here, is I will go through and multiply everything in the numerator. So I've got 325 times 10 to the minus 3. And I'll multiply everything in the denominator. 1 times 10 to the minus 6. I do usually skip that step and just say it's 10 to the minus 6. I will also then finish the calculation for my numerator. My calculator will spin out 0.325 and 10 to the minus 6 in the denominator. Now I enter that into my calculator to give me the final answer, which is with a crap ton of zeros. It was definitely not the intent when I did this problem. 325, I believe. I shifted that right. Whoops, no.
No.
I shifted that wrong. This is why I use a calculator. Where am I? 325 with all of those zeros. Should I include a decimal point? What's the issue with including the decimal point? I'm not saying it's exact, it's still a calculation, but I am now saying all the zeros are significant. Can I say those zeros are significant? No. I started with 3 sig figs, which means we did that. Which means my answer needs to have 3 sig figs. The zeros that I've placed after to get me up into the 325,000, what is the meaning of those zeros? They are placeholders to make sure that 3 makes it into the 100th thousandth place. Thousandths place. Right? And that the 2 is in the tens of thousands place. Right? So they do not hold significant digits. So again, I tend to make mistakes when entering things into the calculator and doing it in my head, as we clearly just saw. Right? This is why I will simplify my calculation down as much as I can before doing any kind of division within the calculator. Okay? There were a few people that skipped steps. Notice that there's just a factor of 1,000 difference between the 3 and the 6. That's fine. The issue with that is you have to make sure you do the 1,000 conversion on the right side, be it the numerator or the denominator. If you're consistently right, I got no argument for you. If you're consistently wrong or even inconsistently right, all I'm going to say is neener, neener, neener. Okay? There's a reason I'm telling you to follow these rules. It makes you consistently correct. Okay? Questions? Yes?
So what you did here was you went back to the original from another modification, and then
Yep.
you did the original to the micro.
Yep.
Okay.
And I shifted between those because those were the only conversion factors I knew. Okay? Because it may very well come out that I can't do it in a single step, which is why I picked this problem, because a lot of people think they can do it, and they probably can do it. But there will be times where you cannot do that direct conversion. You need to break down the steps. And you can do it all in a single line like this, or you can break it into multiple steps, okay, and get a new answer each time you do the conversion. 1 or 2 steps, not that big of a deal. 20, kind of sucks to write out 20 different equations, as opposed to just doing one big long line, multiply it all in, divide it all in. Okay? So it's, again, the formatting, not the answer. We aren't concerned about getting the answer at this point. We really, really want just the format of setting these up. Okay? Is everything metric? Okay? And this is why I don't want you jumping your conversions. Is no, we aren't going to run into everything being metric. We have English units. Okay? Thank you, English. We've got length, mass, volume, and time units that can be different. Inches, pounds, quarts. Okay? We also have cooking measurements. Okay? We've got all sorts of different types of units that could pop up in there. So if we need to do conversions, we have to be familiar with how to convert all of those units.
Wait, there's different units for seconds, but they're the same?
Yeah. Don't look at me. I didn't write it. Okay.
Wait, how come?
So if you look at time, our English unit for time is seconds. It just so happens that the metric unit for time is seconds. And thank God, when we say seconds in metric and seconds in English,
Means the same thing?
we mean the same thing, which is why it's 1 = 1. Okay? Sometimes life is good. Sometimes it's not. All right? To make matters more complicated, when we go through and look at these, if you look at the footnote, how many sig figs are in these calculations? Okay. In the numbers shown, we would say 3 significant digits. Okay. Why is it not 1? Because I look at that and I see 1, 1, 1, 1.
We got lazy.
Because they're exact.
That one's kind of lazy. It's not exact, actually, for most of these. We're really saying that that is actually 1.00 pounds is 454 grams. Is that perfect? No. There's actually a sequence of decimals that could track after that. All sorts of extra numbers, whatever you want to do, or not whatever you wanted to include, but there's a more accurate value for those. Okay, so why do we use these conversions and not the full conversion with all those sig figs? We're lazy. Okay, so what we did was picked a number of sig figs that we think is relatively consistent for this class. That's 3. 3 sig figs works for pretty much everything that you'll see throughout the semester. Not always true, okay, but 3 sig figs we're right around that range. We either jump between 3 and 4. So when you go through and do a calculation, you want to make sure that when you do a conversion that you don't lose sig figs. Because the whole point of the conversion is just to convert the number, not change it. Okay? So if you start with 2 sig figs and you use a conversion factor of 3 sig figs, not a big deal. You stay at 2 sig figs. But what if your measurement is 5 sig figs and your conversion is only 3? Why did you measure the precision of 5 sig figs if you aren't going to keep it in your conversions? So you'd have to look up a new conversion factor that has more sig figs associated with it. Okay? There are some exceptions to this, and this is why that footnote becomes helpful and maybe why we heard the infinity, okay, or the infinite sig figs. The conversion factor between 1 inch n centimeters. How many sig figs? It says 1 inch equals 2.54 centimeters. You say that's 3 sig figs. There's 2.54. What's the footnote say? It's an exact conversion, which means how many sig figs? That one's infinite. So some of these are infinite, some of these aren't. Okay? When you're doing a conversion, use as many numbers as are given to you. Okay? Always use as many given to you. And you got to be careful that in some cases you're using an exact measurement as opposed to one that actually is inexact and you have to count the sig figs. Okay? So let's take a look at some more practice. Go ahead and run through this calculation for me. Length of an American football field, including the end zone, 120 yards. I don't know what it is with the day. What is the length in centimeters? Okay, so we've got a sequence of steps that we've got to go through here. This is not just going to be a hop, skip, and a jump over. Okay, you're looking at least 2 conversions, maybe 3 or 4, depending on how you approach it. You've got some other conversion factors supplied to you. Take advantage of them, see what you can come up with. We're going to run into a couple interesting issues that pop up out of this problem. Okay, so let's go through. I think I need some space to do this. I'm going to erase some of that. Siri is not on the exam. You cannot use Siri. Yards to centimeters does not work, but what can we convert the yards to? I don't want to convert to feet. I don't think we can convert to inches either. I want to convert to meters. Okay. Are inches valid? Actually, where do you even have the inch one? Where are you guys seeing that?
We do yards to feet.
You can do yards to feet and then feet to inches. That's a possibility. Okay. I'm going to do yards to meters. Where's my conversion? There it is. So I've got my conversion down. I know I have that conversion factor, but now it's a question of where do I put the numbers? Okay, well, where should the 1 go? I'm hearing bottom, I'm hearing denominator, and I don't like either of those answers. They need to go in front of yards. Okay? That is a very important distinction because the 1 does not always go in the denominator or in the bottom. It goes in front of yards, the unit yards. Depending on what we're trying to do, that number may change location. So don't think location, think unit. 1 yard. Why do I put it there? Because when I look at the conversion factor, where does 1 show up in front of? Yards. What shows up in front of meters? I really love the enthusiasm there. It's really getting me going. 0.914 is what shows up in front of our meters. Okay? So now what do we do? Meters need to be gotten rid of, and I would ideally like centimeters. Well, this is kind of nice. Why is this nice? Do I have a conversion factor between meters and centimeters? Yeah. What does centi mean? Centi means 10 to the negative 2. The power of 10 always affects the base unit. One centimeter is 10 to the negative 2 meters. I got all that open white empty space. I go, oh, I didn't fill it in. I don't care. Who cares? It's not a big deal. You just wasted some paper. Yeah, I could go through and do my units really big. I won't do that. If we go through and solve it this way, did anybody solve? Oh, first off, did anybody solve it with this method? Okay, now be quiet, everybody else.
I screwed up right here.
Ah!
I put 10 with the 2 on the top, so I might have ended up getting the same, but I didn't.
Your decimal would have shifted. So give me your numbers. 1, 0. Should have gotten 1, 0, 9, 6, 8. I heard a couple people going, wait, it was 7, 2. Not 6, 8. We have an issue here. Depending on how you solved the question, you get a different number. We'll talk about that issue in the next thing. Okay, so you have to be careful with when you go through and adjust these things. And when you come to a problem, particularly on an exam, there could be several ways to go through and solve it. So you may end up getting a slightly different answer. On an exam, you've got multiple choice. You can kind of match whichever one's closest. On mastering, you may run into a problem here if you solved it using slightly different conversion factors than they did. So try to make sure that when you solve the problems within mastering, you use whatever conversion factors they give you. If they tell you 1 inch is 2.45 centimeters, I don't care what it is. Mastering is telling you that that is the answer, that that is the conversion. Use it. Because if you change from what they are telling you is the truth, you will be marked wrong. That's how it gets calculated. Okay, so if they give you a big string of conversion factors, use their conversion factors. Okay? The next issue with this answer is still wrong. Okay? Because there are way too many sig figs in this answer. We've got 5 sig figs coming out of this. How many sig figs should show up?
2.
Oh, we got that 120 there. So we can go through and take a look at this and kind of debate sort of all day about the sig figs involved. In our conversion factors, okay, let's start with the last one. How many sig figs in that conversion factor? It's infinite. There are exactly that amount of centimeters in an inch, centimeters and meters, okay, or meters and centimeters. That is an exact conversion. Within the metric system, they are all exact infinite sig figs. Next one. Okay. This comes from information that we'd be given. According to the information we're given, are we told that it's exact?
Yep.
Are we?
No, pretty much, sure.
I'm going to say, I don't think we're told it's exact. We're just told that number. So that means we're running this at 3 sig figs. To start, how many sig figs? I'm hearing 2 and 3. Be very careful. Is the number given in our problem given with a decimal point? No, which means we need to use rule 2, okay, which says with rule 2, our 0 becomes significant if and only if there is a significant digit to the left and to the right. When we look at that 0, to the left, yep, we're satisfied. To the right, no significant digit, which means there are only 2 sig figs, which then means our answer needs to be 2 sig figs. We underline 1 and our 0. Our first insignificant digit, the 9. What's its relationship to 5?
Higher.
It's higher than 5, so what do I do?
Round up.
Add 1. And my number becomes 11,000 centimeters. Which brings up the next issue. Why can I include those zeros? Without the decimal place, those zeros are acting only as placeholders, not as significant digits. Okay? That makes the number 11,000, not 11. Right? We played on an 11-centimeter football field. That'd be kind of easy, I guess. Or really hard, yes.
So on the test, the answers are going to be, that are optioned out will be used with significant figures? Or like we're supposed to answer based on...
So where this shows up on an exam, this is this conversion requires multiple steps. More than likely what you would see would be 5 answers, all having done those multiplications or divisions differently. So one answer would be our 11,000. One answer would be 120 divided by 0.914 divided by 10 to the negative second. Another answer would be 120 times 0.914 multiplied by 100 divided by 100. Okay? So all we're going to do is different permutations of each of the conversions that you should have done along the way. What does that end up meaning? If you don't know what you're doing and you just multiply, divide some random numbers, you will get an answer that's on the multiple choice. That answer will be wrong. Okay? So when you attempt a multiple choice test, if the test was built well, which I like to think I build them well, all answers are things that a calculator would spit out at you with those sequence of numbers given. Okay? So you cannot just, oh, it gave me an answer. That doesn't work. You have to understand why and how to get to that answer. Okay? There are exceptions. Sometimes I'm just an idiot and don't know what I'm doing. Okay? Almost always you'll see an answer that's the equivalent of saying goats. Okay? I'll say 11 centimeters. Okay? If anybody looking at this question would probably say that 11 is a possible number, but it makes no sense with the size of a football field. And so it could eliminate that answer. Okay? If this was a sig fig question, okay, let's drop in, because I can't do all the math for all the wrong answers for the other one, but I can do the wrong ones for the sig fig question. If this was a sig fig question, sorry, let me try that again. So let's ignore the units because they'd all be centimeters. I'll give you 10, 9, 6, 8. I'd give you 10, 9, 7, what was it, 2? Okay, I need 5 answers, so thank you for that other one. 10.97, whoops, 10,972.8, because that's exactly what your calculator spits out. And I'd probably give you the 10, 9, 6, 8. What is the decimal after that one? Anybody do it that way?
That's 0.8.
That one's 0.8?
Oh, just kidding. I
No,
don't know.
so
Okay, let's say it's 4. Oh. Okay. So now you've got all of these answers. Which of those is correct? Well, if it's a sig fig question, this is how it gets phrased. Okay. All of those numbers are things that you could theoretically come to, okay, to some extent or another. You need to make sure that you understand both the math and the sig fig calculation as it runs through. Make sense? So the answer in this case is R11,000.
So it's always going to be a sig fig question?
No,
How
it
is
will
it
not always be a
different?
sig fig. So the other way that it would get asked is I would take 120 divided by 0.914 as opposed to multiply. That's going to change the number. I'll put that number as an answer. If I was going to ask this question as a sig fig question, these are your answer choices. Okay, so depending on what I'm asking, you'll see different answer choices. Other questions? Don't look too excited. It's not that bad. Yet. I thought that was funny. Okay, new problem. Harry has 100 pennies. Douglas has $3 bills. Sally has 30 dimes. Oh, you're going to love this. Harry wants to exchange his pennies for dollars. Douglas is infatuated with silver things, and so will only exchange his dollar bills for silver objects. What does Harry have to do to get his pennies converted to dollar bills, and how many dollar bills can he get?
All right. You can get $1.
Yes, we're going to do the stupid word
So
problem.
He has to get
you
10
might be able to
pennies
jump
from
all the
Sally.
way through and get your answer, and then if we break it down into the individual steps, Harry has to go to Sally
For 10.
to get the dimes. Once he's got the dimes, then he can go to Douglas to get his dollar bills. So you are forced to go through each of these individual steps. Why did we give you these stupid word problems in mathematics? Because these stupid word problems give you the format that you use when you move into chemistry or physics, where you don't have any understanding of what those units mean or the conversions between them. Right? So theoretically, you'd be able to process all of this. And you probably wouldn't have too much of a hard time of it. But if we switch it around, Harry now has Snorlaxi. He wants to get them converted to Skittle farts. Douglas will only exchange his Skittle farts for silver objects. What does Harry have to do to get his Snorlaxi converted to Skittle farts, and how many Skittle farts can he get? You now have zero comprehension of what these units mean. Okay? Now it's at least kind of funny looking. Okay? I don't know. So now what we have to do is come up with a new format. We can't wrap our brains around this one quite as easily. because the units have now all changed into things that completely make no sense. You now have to set up a format where those units, regardless of whether they make sense or not, allow you to convert all the way through. Okay? I should have changed the 10. I did change it earlier. So how would we go through and approach this? What do we want as a final answer?
Sally can get 3 Skittle farts.
What do we want as a final answer?
You want a Skittle fart.
We want Skittle farts.
How do you call this units? What's a Skittle? Why?
I have no idea.
Could be like
Did you ask Einstein while he was a genius? Harry wants his Skittle farts, and he's starting with his Snorlaxy. Irrelevant to the question.
But are they shiny?
Okay, we know nothing about whether they're shiny or not, so we have to assume that they aren't. So what do? How can we get Snorlaxy converted into Skittle farts? So we'd run through with our Snorlaxy and our Skittle farts. Do we have that conversion? Don't skip steps. There is no direct conversion there. We have to go to dimes.
But common sense though.
Common sense does not tell you anything. And in fact, on an exam, common sense tells you the wrong answer. Okay? Roughly 75% of the time. Where did that come from? Multiple choice exam. I'll challenge that one after the first exam.
It's usually always all the above as well.
You have to come up with a format. Okay? So you at least getting the idea that we have to have this formatting to go through and approach these. Because while these terms and units may look really weird and bizarre and funny to say, when we shift to moles or atoms, those units don't sound quite as funny, but you're running in the exact same issue. You have to be able to have a reference to allow you to do these conversions. Okay? Kind of makes sense? Okay. Compound units. A motorcycle is traveling at 105 kilometers per hour. What is the speed in meters per second? And that thing should not have shown up yet. Okay. How far did the bike get in 120 seconds? How long in hours to go 90 miles? Okay. We have a compound unit showing up here. What is that compound unit? Kilometers per hour is our first compound unit. We don't have to convert grams to milligrams, okay, or inches to another distance. We can convert compound units. I can convert kilometers per hour into meters per second. Okay, so let's ignore the thing in the middle that wasn't supposed to show up yet. If I convert meters to second for that first answer, the answer I want is meters per second. What do I start with? Kilometers per hour. And we compare starting our, I keep calling it a reactant product, calculation to answer. Is kilometers equal to a meter?
No.
Are hours equal to seconds?
No.
No. So I have to convert both units. Which unit do I convert first? Does it matter? We're doing multiplication and division. Multiplication and division are communicative, which means it does not matter which one I decide to convert first. Which one do you think is easier to convert? I agree. I think kilometers is easier to convert. So we'll look kilometers. And what unit do I want to get into? Meters. What is the conversion between those? Kili equals kilo. 10 to the third affects our base unit, 1 kilometer. What unit am I now in? Careful. Meters per hour. So I'm getting closer because now my meters unit is correct, but my hours is incorrect. So what do I do now? I need to convert hours into seconds. Where should the seconds show up?
Denominator,
Why the denominator?
because the hours and
reverse logic on that, but yeah, there's an easier answer for why seconds needs to be in the denominator. It's in the denominator in our answer. So we could put seconds and we could put hour here. How many of you know the conversion between seconds and hours? Some people do. If you don't, can you convert to something else? Convert to minutes. I don't care what the answer is. I want the units. It's the setup. Okay. So we now look at our units. Okay, we've got minutes and seconds. What's our conversion? What numbers need to show up in there? 1 minute is 60 seconds. I got the seconds, but now I've introduced minutes. I don't want minutes, and I also don't want hours. So what can I do? $60 minutes and 1 hour, true, but I want the units. Where should the units show up? Hour needs to be in the numerator because it needs to cancel with our hours in the denominator at the beginning. Minutes in our numerator because it needs to cancel there. What's our conversion? I see it. Give me a sec. 60 minutes is 1 hour. Yes?
Why wouldn't you start with the larger units?
Doesn't matter. So it just comes down to what was shouted out first. Someone said minutes, so we went with minutes. I would probably stick with hours first because I could cancel the hours right away. That is cleaner to me. Doing the 1 minute is 60 seconds is a bit dicey because I don't cancel anything, and all I've done is introduced another unit that I need to get rid of. Okay, but ultimately it does the exact same thing. Okay. Now I can put in my initial number, which was 105 kilometers in 1 hour. I could take everything in the numerator, multiply it out, and get a number. Everything in the denominator, multiply it out, get a number, and then divide my numerator by my denominator, and I'd have my final answer in meters per second. Okay. So I am noticing that some people have found there are conversions for these units in your calculator. That's fantastic. There is a really simple dodge on my part to prevent that from popping up on the exam. When and how, that's the not nice dodge. I could change the unit to something that doesn't make sense that's not in your calculator. But then the other way is when and how do I ask this question? Number one, on the exam. There are 2 ways I can ask questions on the exam. What are those 2 ways? Multiple choice and short answer. If I ask this in the short answer, I don't care what number you get at the end. The only place that you get points is for your work. Okay? So you can punch in whatever you want into the calculator. If you don't have any work for it, I'm not giving you any credit. Okay? Very simple dodge. Okay? You can check your work all you want in the calculator. That's fine. Okay? And if you want to figure out how you can get those unit conversions, probably have to talk to someone other than me because I don't really know. Okay? But they are there. So what we've got in this case is just an example of compound units. You just have to break it down, look at the components within that unit, and slowly process your way through to get your units appropriately converted. Okay? Questions? Do we want to do the rest of those? I heard a sure, so sorry, we got to run one more. Let's do the one that, this guy. I'll let you guys work on this one by yourselves. As a general hint, you can see that the format is already set up. You need at least 1, 2, 3 conversions to get through to the final answer. How far did the bike get in 120 seconds? And I've added the term in kilometers. Why do we need the in kilometers? Why do I need to know the units of the distance? How far we went, but what if I had actually asked in inches? Is that going to change the number? Yeah, it's going to be a massive change in it. If you ever get a question that is just how far did this thing go with no units, you have no answer. Okay, there's literally nothing you can do to answer that question because you don't know what units you need. The units must be included. Okay? So take the next couple minutes to go through and see what you can get through. The first place, as we've been dealing with, put down what you're trying to get to. We're trying to get to kilometers. Right? So we can put that as our final or our end point. The next part is what information are we given? How many pieces of information are we given? Two. We are given that it's moving at 105 kilometers per hour, and we are given 120 seconds. Not a different question. You would need to know the speed it's going at to answer this. Okay? So with those two pieces of information, we can start with those in any way we see fit. Okay? Most people will start with the 120 seconds. Okay, so let's see if I did that. There it is, 120 seconds. Okay? So our next process would be, is there a direct conversion between seconds and kilometers? Anywhere in our question do we see seconds and kilometers as an exchange? No. Okay? So we don't have that direct conversion. We're going to have to convert either kilometers or seconds into a different unit and hope that we can then convert our distance and time. Okay? So that's where identifying what unit we've got can help us. Seconds is a measure of time. Kilometers is a measure of distance or length. What's the other piece of information we're given? 105 kilometers per hour. What is kilometers? A distance. What is hours? Time. That factor allows us to convert between time and distance. What are we trying to do in our conversion? Convert between time and distance. It is there for us. It's maybe buried in a bunch of other units, but it is there. Okay? So now the question is, how do we work through this? And it can be done in a variety of ways, and it's going to be a surprise to me to see what I wrote up here. What did I write up here? I went through and dropped in the kilometers first. Okay? I know I want kilometers in my numerator, so my first conversion is to get kilometers in my numerator. Does this fix my seconds and hours unit problem? No, and in fact made things worse. But can I convert hours or seconds into something else that allows me to cancel? Yes. I could potentially go seconds into minutes. Now my seconds cancel and I've got minutes. I still have this big, messy, complex unit. But can I convert minutes into hours? Now that all of my units are set up, I can run my numbers through it, punch it into the calculator, and we should end up with 3.5 kilometers. Okay? The organization is setting your units, numerator, denominator. You only have two options. Look at where they best fit. Questions? Okay. I really don't like dealing with percents, but percents are really an example of unitless information. Okay? Percent literally means division by 100. So we're looking out of 100 parts. That's kind of the point of a percent. Okay? So if we looked at grades, okay, if you got an A, more than likely, what's your percentage? Greater than 90%. You got 90 points out of 100. That's all a percent is talking about. So it's the one quantity out of the total sample, and since it needs to be out of 100, we multiply by 100% to get our percent. Okay, and then we can report everything as a percent. If we want to go through and do any calculations, we have to take it back into the decimal. So a 90% becomes 0.9 whenever you do a calculation. Okay? So if we take a look at an example, bronze is an alloy of copper and tin. Sample of bronze contains 79.2 grams of copper and 10.8 grams of tin. What is the percent copper in bronze? How much tin is in 100 grams of bronze? Right. Again, we're relatively good with 100 values, so most people can, or some people can pick out these differences pretty quickly. Okay, but if we want to figure out our percent, in bronze, percent copper, that's going to be the mass of copper divided by, careful, divided by the mass of the bronze. It's the percent copper in bronze. So it's our mass of copper divided by the mass of bronze. Well, what's our mass of copper? 79.2. What's our mass of bronze? Okay. It's going to be 79.2 plus 10.8. Is it really 100? I didn't think I was that good with my numbers. Isn't that 90?
Yeah.
And we get 79.2 grams of copper divided by 90.0 grams of bronze. Punch it into the calculator, multiply by 100, and we get a magic number of,
8%.
say 88. Yep, that makes sense. Answer being there in the lower right-hand corner.
Yeah, I was gonna say.
And we've got, if I make it any smaller, I can't read it. 88.0% copper and bronze.
Just should circle the text.
Okay, so we've got it kind of set in within that question. If we want to know how much tin is in 100 grams of bronze, what do we have to do now? We need to figure out the percent, first off, of tin in bronze. What is the percent of tin in bronze? What makes up bronze? Copper and tin, right? If copper makes up 88.0%, what does the tin have to be? Why does it have to be 12%? It's out of 100, right? So if we add the two of those, it had better equal 100%. Okay? Because those are the only two things present. So if we're now looking at 12% in a 100-gram sample, well, we can convert it to our decimal, 0.12 times 100 grams, which gives us 12 grams of our tin. I shouldn't be doing that because you guys shouldn't be doing that. That should be a lowercase n. Okay? Questions about that? Percents will come back and haunt us. Not nicely. It's usually what haunt means. It's usually a bad thing. Okay, let's take a look at some volumes. These are nice and tricky things to worry about. Volumes are three-dimensional objects. Okay? Everybody agrees, yeah, volume's three-dimensional. That's what we're looking at in chemistry. The units that we come up for this ultimately come from how we could calculate volumes. Well, if we look at a cube, what's the volume of our cube? Length times width times height. Relatively straightforward, we got that figured out. But what is the volume of this three-dimensional object? And this is now coming out at you. That becomes a little bit less easy to calculate.
This is something you can hold, just dump it in some water.
Okay. So we have to come up with other ways to measure volume. One of the ways that we go through and do that is using a different unit from length. Okay. So we can look at our unit being, our base unit of liters. And this is really to take into consideration that we can't measure the volume of all objects easily. But what we can do is compare them to other things. Okay? And our volume measurements we can use by dealing with water. Okay? So our base unit is liters. Our liter volume is defined as the area or the volume of a cube that is 10 centimeters by 10 centimeters by 10 centimeters. Which means, what's the number associated with that? I don't know, it's kind of a weird thing. If we did that 10 centimeters by 10 centimeters by 10 centimeters, what do we end up with as a unit? 1 liter equals 1,000 centimeters cubed.
Almost like 1 milliliters or 1 centimeter cube.
It's the same thing.
Yeah.
Okay. This unit of centimeters cubed is kind of our length unit. It's kind of an interesting unit. It becomes dangerous when we go through and do some conversions, which we'll talk about in a probably on Thursday, if I'm going to be honest. Okay. What happens if we now try and convert this into milliliters? Okay. So what's our unit factor conversion between centimeters cubed and milliliters? So I want to know how to relate those two.
Equal
Or like 1 to the 10 to the negative 3, and then 1,000 to the 10 to the negative 3.
So how can we go through and approach this? 1 liter equals 1,000 centimeters cubed. I want to know how many 1 milliliter equals of centimeters cubed. Okay, so what we would have to go through and do is do all of our conversions. What's our conversion between liters and milliliters?
10 to the negative 3.
10 to the negative 3, which happens to be
The same as centimeter.
the opposite of 1,000. So what's 1,000 divided by 1,000? 1 milliliter is 1 centimeter cubed.
And then also written as cc, something like that.
If we shift to the medical field, they decided to bring in their own unit system because they thought cc sounded cooler than mLs. Right? And what is cc?
cubic centimeters.
A cubic centimeter. It's the exact same thing as a milliliter. Right. So what we're looking at is now a way to convert between a distance measurement and a volume measurement. Okay, I don't expect you to pay attention because this one's a bit of a beast on trying to solve, so we'll pick up this one on Thursday. But what we're going to look at is trying to convert our volume measurements, okay, where we're using distances as opposed to our liters or milliliters. So attempt to solve this problem. We'll pick it up with that on Thursday, and with that, I'm done 1 minute early.